filters will make this mic sound amazing. And the first filter you can add is a gain filter. And so there will be people that did set their microphone to 100%.
Process step by step from wiring and coding, testing from the prop. So Good evening, everyone. My name is Fred. Hope you can hear me and you can see me. If you can see me and you can hear me, can you clap twice? Can you write on the comment section? You can see me and you can hear me. Confirm that. On the chat, can you confirm if you can hear me well? Am I loud? Am I clear? I know my camera is not that okay. My lighting is not that fine, but if you can hear me well, kindly tell me so that we can continue. Let me confirm from my end. Just write on the chat. Can you confirm if you can hear me well? Am I loud? Okay, thank you. I think the reason why we are using YouTube today is because YouTube doesn't have much restriction, doesn't have so much restriction when it comes to timing. You can stream as long as you want. You can even stream for more than 72 hours, for more than even a week. You can even stream for a week. But now, as opposed to Google Meet, we have to, it limits us to 1 hour if we are on the free package or unpaid package. But if we go the paid version, we can even extend the time. But since this thing is very this course is free of charge, I'm not charging anyone to come and watch or to learn. I'm not going to pay for it since I'm not collecting any amount from you guys. So we are making it to be free of charge. So that's why we have opted for YouTube. Welcome, guys. So let's continue. Let's just continue. I'm just going to switch off my camera so that I can concentrate and so that you can see the entire screen. So allow me to switch off my camera. In case you have any question, you can just text on the comments section. Yeah, on the chat. On the chat. Yeah. So thank you. Thank you. Thank you. Okay. Sorry. Let's continue. Oh. So yesterday we did, let me just do an overview of what we did yesterday. We did overview for robotics, for the maze solving bots, and we said we are going to use two-wheel drive maze solving bot, and the components used, we were on that. I'm not sure, but we'll see. The component used for that robot, which components should you use for that robot? The algorithm, that is the coding, which algorithm are you going to use for the robot to make decision, the coding and calibration, yeah, like how are you going to code, which language are you going to use. So algorithm is basically, it's not a programming language or any concepts of programming language. It's just like the technique you are going to use. Like for example, you see this robot, it has 4 wheels, wheel number 1, 2, number 3, number 4. So if we want this robot to turn towards left, assuming this is the front where the batteries are, if we want the robot to turn towards left, what we do, we just make these wheels to stop and these ones to move forward, so the robot will turn towards left. Or we can also make these wheels, the two of them, to move backwards or reverse, and these ones to move forward. Then the robot will also achieve the same the same movement, that is turn left. So basically that is the algorithm. Anyone can understand about, can even explain about algorithm without even knowing anything to do with a programming language. So that is it in a layman's language, can just explain about algorithm. So now we have coding. Coding is just like the programming language we are going to use, and the instruction we are going to give the robot for it to be able to move. Then we have navigation and testing. We are going to navigate to try and test the robot. So yeah, we are going to like fine tune those parameters of adjustment, like the speed, like the sensor sensitivity, and we are going to test. Then optimization, how are we going to make our robot to be more efficient, and enhancements, how are we going to enhance our robot to be more like versatile. So let's just let's just get started. I just want to go live on TikTok also. Yeah, so let's continue. In case you have any question, make sure you comment on the comment section. I'll be able to answer. In case you have any question, you can either comment there. Yeah, just comment there. I'll be able to address it. Yeah, so let me just go direct to this slide. There's a slide where we left yesterday. I think we did about the here. I think it was here, the bill of materials which we need: Arduino Uno, the microcontroller. We'll also need the motor driver. We'll also need male to female, or female to female, or female to female, male to male, and male to female basically. Then we'll need a laptop. We'll need a laptop to program, and we'll need also the basic understanding of C++, that is Arduino. Yeah, so this is a circuit diagram. I think I explained this, if I'm not sure, but for the sake of those who were not in, let me just go ahead and explain. So here you can see we have left motor, we have right motor. Basically our robot, if you're using four-wheel drive, you are going to have two left motors, and if you're using four-wheel drive, also you're going to get two right motors. Yeah, then we'll have our main microcontroller, which is Arduino Uno. This is the main microcontroller. This is the main microcontroller. Then you'll get two IR sensors, but I prefer three IR sensors because one sensor must be on the line. Then the extra two sensors can be on the white surface so that we can map them easily. Then we just need to power our whole project using you can use a source of power which is more than 7 volts. You can use 12 volts to up to, I think I did the limit was around 24 volts. I'm not sure, I'll confirm about that, but there's no much limit on that, especially in this category. So we're going to need a source of power which will be able to power the Arduino, and will be able also to power the motors and the IR sensor. So basically when we are powering the whole circuit or the robot, we're going to power it via the motor driver, which is L298N, and we can power it from VMS power supply, which can take from around 7 volts to around 35, actually to 35 volts. Yeah, then it will be able to supply 5 volts through ground and 5 volts output power to the microcontroller. And from the microcontroller we are going to power the IR sensors. Actually we are just going to need 3 IR sensors. So in case you have any question from there, you can ask on the chat. I'll be able to see and respond on that. Yeah. Yeah. Okay, let's continue. So we have a left hand rule. Yes. Also, if you are on TikTok, yes, Mr. DIY, hi. If you have any question there, you can just comment. I'm going to address. So we were using left hand rule, and I was explaining yesterday what is left hand rule and how a robot is able to maneuver and find its way out using the left hand rule. Yeah. So yeah, I also explained this. So the major actually, up to this point, there's someone who was asking me about what he was asking me about the algorithms, the coding. I've gone so much, so deep, and I've not taught anything to do with programming. Basically, there's nothing about programming here. I haven't even touched anything to do with programming here. This is just basic. Like, I'm just explaining how the robot works in a layman's language. Yeah, so don't worry. So actually a maze has these things. It has a junction. You can see this is a T from here to here. Then this is a T junction. Sorry, T junction. Then let's see, at crossroad. Let me show you a crossroad. Okay, this one doesn't have a crossroad, but I'll show you in another one. And then at dead end, you see this one, stop. This is dead end because after here we are not going to have anything. Yeah, that is the dead end, and the robot should stop. Yeah, when the robot reaches the end of the maze, it recognizes the goal. At this point, no further movement is needed. The robot stops completing its mission successfully. So if your robot still continues to move, then you lose it. You lose it. So yeah, let's continue now. This is a very simple example of a maze, but this is not what we'll have in that day of competition. Let me show you what we are going to have. Yeah. This is just basic algorithm which we use to explain how the robot places its left side on the wall, uh, at start number 1, then move to 2, 3, 4. Each time it reaches the corner, it turns left if possible. Yeah, that is like basic explanation. Then yesterday I explained on this maze. Actually, make sure you understand here. If you don't understand this part, you're not going to understand even when we come to the coding part. So just make sure you understand this, and you are going to you're going to be good. Yeah, so let me just explain how a robot is going to maneuver. As you can see from here, our robot is supposed to come from here, point number 1 at start, then to the end, number 15. So let me just explain how our robot will be able to come from here to here. As you know, we have several algorithms, several ways how we can make our robot maneuver. Number 1, which is very simple for beginners like you, we can use a left hand rule, which says a robot should keep left, should take left, should take I think what is it? Let's say left exit whenever it's possible to do that. Yeah. So from number 1, a robot will come to this junction. Actually, this is called crossroad. Yeah. Crossroad is just like a road which is crossing another road. Yeah, passing by. So at this crossroad, our robot should turn left. Number 1, as you can see, it has turned left. Then at here, this is the end of this branch. The robot should turn left. Actually, this okay, it's a U-turn. Even if it will turn left, it will do a U-turn. Yeah, towards this junction again. But here again, it will not continue moving because we have another branch here. It will turn left, regardless, turn left, then it will go up. At this point, the robot will also turn left here, this way, then move to this point. At this point also, our robot will turn left again because we told the robot to use the left hand rule. That means the robot should always turn left whenever it's possible. So the robot should turn left. At this point, the robot should turn left again, like U-turn. Yes, then go straight. At this point, the robot, at point number 7, the robot should turn left, which is there's no any other option for turning left, so the robot should continue straight. So it will continue straight to number 8. At this point, the robot should turn left, that is U-turn. Yeah, up to this point. At this point, the robot should turn left. The left of the robot is this side, so the robot will turn left. At this point, the robot should turn left again. At this point, also number 11, the robot should turn left, that is U-turn. At this point, the robot should turn left, but since we don't have any option available for left turn, okay, like there's no branch for left, that means it will try to turn left as it move forward, so it will move forward. At this point, the robot will also turn left. At this point, turn left. Then it should stop at this point, since all sensors will sense 0, that is low. The sensors will be low, then the robot should stop at that point. Do we have any question up to that? Let me check for any question. Oh nice, we don't have any questions, so let's just continue. Yeah, so I explained that yesterday. So simplifying or optimizing the path. So let me tell you, you see in the last slide, the robot took 15, I think 15, 1, 2, 3, up to 15 moves for it to be able to reach at this point. But now we can combine left and right, so the robot will only use two turns. Actually, it will go through two intersections. I'm make two major decisions for it to reach the final destination. So let me explain to you. So at this point, the robot should turn right. Then at this point, the robot should turn left. Yeah, then it will reach the destination. Now we can also decide to use only right hand rule. Sawa, right hand rule, which means the robot will always turn right. So at this point, the robot will start, go forward. Then at this point, the robot should turn right this way. Then at this point, the robot should turn right again. You see, at this point, it will not turn left. It will continue straight, since there is no any right turn which is available. So the robot will continue straight. At this point, the robot will turn right. That is, make a U-turn. Make a U-turn. Then at this point, the robot will continue again. Sorry. But then let me just see if this is possible. I'm not sure. At this point, the robot should turn right to this point. Then you turn here at this point, right turn at this point. So you see, the robot will never come to the destination because it is using the right hand rule, and there's no way the right hand rule will take it to the final destination. You can see that. So what the robot will do, it will like maneuver from this point start to here, then back to here. It will continue doing that. It will continue doing that forever. Now you see, so whenever so whenever you are implementing an algorithm, you are using any algorithm for the robot, it must be so logic. Like, is it going to make the robot attain its objective or the goal? If it doesn't, then your labor is in vain. So make sure you first do research, you like gauge and see if the robot will be able to achieve using which rule will take shortest path and shortest time. Because I think you have read the rules for these competitions, and especially for the maze solving bots, whereby we said the robot which will take less time and it will definitely stop at this end, it will be declared the winner. Yeah, that is it. So your robot must take the least time, and it must be very accurate from here to here, and it should follow the line or try to make to trace the line towards the end. So that is it. Do you have any question? Let me check the comment section. There's no question. Sandra Wambui, sorry, you guys, can you hear me? See here, I don't understand what you are saying, Sandra, but hope you can hear me well. A book, just comment there you can hear. If you can hear me well, just comment. I'm not sure. So let's continue. Okay, this was the first one. You guys, you can follow me on TikTok at Miss Ardino, and these are the WhatsApp channel. You can take a screenshot. You can join the you can join what? You can join the community, WhatsApp community, and also you can join. You can follow our channel. That is our channel link. Yeah, you can just follow. So that is it. Do we have any question? Any question? Let me tackle any questions. Any question about maze following robot? Oh, nice. Science TV. I think I am audible according to you. Audible. Audible. So basically, you guys, I want you to let me just do something so that tomorrow we can start coding, and I'll explain some bit about coding. Yeah. So let me just do some few introduction, not introduction, but recap about the rules, the game rules. Let me just do game rules a bit so that we can call it a day. In case you have any question, you can comment there, and you can register for the event. Actually, the link is out. You can register for the event. It's free. It's free for the spectators. If you just want to come and watch, you can come and watch, and yeah, it's free for you. You can there's a link in that channel. It's a channel. So what's up maze solving bots guidelines and game rules. So let's just take a look on the game rules. In case you have any question, you can ask. So okay. Let me try and project. So yeah, so if you guys, you can see my screen well. You tell me if you are able to. Yeah, so this is my screen. You see I'm the producer and I'm also the speaker. So if I delay little bit, don't worry about that. Yeah, which software of coding are you using? We're going to use Arduino IDE. Arduino IDE is very simple and it's free of charge. So that is the software we are going to use, and yeah, it's free. I'm going to show you how to download it and how to install. Yeah, tomorrow which software? So make sure you install Arduino IDE in your laptop in Windows, Linux, and any operating system except Android. How will the bot make a U-turn? By the way, that is a good question. That is a good question. So it's very simple for a robot to make a U-turn. Yeah. So let me just explain. But you guys, are you sure you are able to see the in your screen? Can you see maze solving bots competition guidelines, or what are you seeing in your screen? Because that is what you are supposed to be seeing. I don't have another window where I can preview. Yeah, I think you can see. I've seen now. I think you can see that. I'm sure. I'm not thinking, I'm sure. So, what we're going to do, um, let me just explain how the robot does a U-turn. So I'll roll back to the previous slides like this. Then go back, go back, go back, go back. Go back. Yeah. So let me just, I have already done that. I explained. I think you just joined. Let me just explain. Yeah. You see this robot. You see this robot. So this robot has 4 wheels. We have wheel number 1, 2, number 3, and 4. So let me just say we have this pair. Actually, they are just in parallel.